The Swabian Alb. Gentle slopes and dreamy meadow orchards. But the idyllic landscape is under threat. Local construction firms have their eyes set on the Jura limestone. It forms the foundation of the Swabian Alb. And several million tons of it are disappearing each year. Large trucks transport the stone to a nearby gravel plant. Gravel is an important raw material for the production of concrete, and large quantities of concrete are in great demand in a region known for its dynamic construction sector. There are more than 40 stone quarries in the Swabian Alb alone. Many more throughout the state of Swabia, and hundreds in the other central German uplands. Additional gravel pits located along major rivers like the Rhine, Donau, Main, Weser, and Oder provide even more of the coveted material to the construction industry. As a result, some 4 hectares of gravel are dug up or blasted away every day in Germany. Each year, that equals the area of a small German town with more than 10,000 inhabitants. It's an enormous use of natural resources. In addition, most construction takes place in high-density urban areas, while most gravel pits and quarries are located far outside the cities. Trucks transport millions of tons of stone along German roads to construction sites in the cities. This form of raw material procurement not only takes its toll on the landscape, it also leads to higher energy consumption. But the raw materials are closer than we think. German cities are full of them. Many structures in Germany were built sometime between the 1950s and the 1980s, and they're mostly made of concrete. They'll have to be renovated from the ground up in the coming years, and many of the interiors will have to be modernized to meet current needs. The fact is, many buildings are in dire need of renovation, and some are ready to be demolished. Take this foundation structure of a former factory building in the south of Stuttgart. A hydraulic chisel breaks up concrete and masonry on location. An excavator dumps the material into a crusher. The crusher processes the parts into recycling material with a particle size of up to 60 millimeters. A screening unit then separates the gravel into various particle sizes. The recycled concrete can be used as the frost-resistant material FSS 045, forming the foundation of this future parking lot. The problem is, concrete recycled from old buildings will have to be used in the construction of new buildings in order to increase the total proportion of recycled materials. And that's important for the conservation of natural resources. The principle is put into practice at the recycling center of the Fes Erdbau Company in Kirchheim-Teck. A variety of concrete and building rubble materials are processed for reuse here, covering an area of 30,000 square meters. The rubble is collected within a radius of 15 to 20 kilometers from the recycling plant. Since the material can be sorted here according to type, only pure concrete ends up in the crusher. A magnetic belt removes the steel reinforcements. The result is a clean fraction with a size of 2 to 16 millimeters. Nearby concrete factories use this material to replace the gravel from stone quarries or gravel pits, saving natural resources. The Swabian building material experts also process masonry and even roofing tiles. Using a special screener located in the bucket of a wheel loader, material can be separated from plaster remains, small particles of wood, and sheeting. The resulting fraction also makes its way through the crusher and into the recycled concrete. Because of its careful gathering and perfect sorting, FACE is able to recycle 80 to 90% of the demolition waste. That's around 1/3 more than usual. One buyer of the recycled aggregate is the Minnende Frischbeton concrete manufacturer. Located just a few kilometers from the recycling center, the company uses the so-called recyclate for the production of fresh concrete. It procures scrap concrete from a variety of suppliers in the Stuttgart area. A bucket conveyor lifts the recycled rubble into the concrete factory's storage area. There, other chambers contain different aggregate materials used for the concrete, including natural and crushed sand and a fraction of shell limestone chippings. The mixing device combines these primary raw materials with the recycled secondary materials. Then comes cement, water, and the construction chemicals required by the recyclate. Current guidelines allow up to 45% of the mixture to contain processed concrete rubble. The resulting product is a recycled concrete that meets the industry's quality standards and technical demands. Normal concrete mixing trucks deliver it to the nearest construction site. It has the same viscosity as normal concrete, making it just as easy to use as the conventional material. And it's just as resilient. Guidelines require a so-called strength class of C3037. Weaker classes are also admissible for mild frost and acid exposure. Recycled concrete has been widely accepted on the market. Customers are satisfied with the quality. It's almost the same as conventional concrete, and it's allowed us to save 30% on primary raw materials. The new material is further tested in a laboratory at the Krieger Group in Neckar-Rems. The engineers hope to increase the 45% maximum proportion of recyclate currently allowed in concrete. They're preparing a so-called compressive strength test. A sample cube with an aggregate of nearly 100% concrete rubble is positioned in the device. Then pressure is slowly applied. The currently admissible strength class requires the sample cube to withstand a force of well over 700 kilonewtons. That equals the weight of more than 60 mid-sized cars. The test shows that recycled concrete made of 100% recyclate can withstand the required strain. That means it could contain twice as much concrete rubble as previously allowed by law. Engineers are carrying out additional tests with recycled concrete samples in the lab's cold chamber. These tests indicate that recycled concrete is far more resistant to frost and de-icing salts than previously thought by lawmakers. The state of Rheinland-Pfalz has a research project aimed at changing current regulations to substantially increase the amount of recycled aggregates used in concrete. It's also aimed at processing all the materials found in construction waste in order to reuse them in further construction. That would create a closed cycle of materials within the construction industry. The first building that used recycled concrete was constructed in Rheinland-Pfalz. Along with Berlin and Baden-Württemberg, the state plays a leading role in the use of environmentally friendly building materials. Recycled concrete has long been found in buildings like this housing complex in the Swabian town of Winnenden, and in the foundation of this arched bridge in neighboring Backnang. Examples from Switzerland demonstrate that recycled building materials can also be used in large-scale construction projects. And recycled concrete is shown to possess many more capabilities than current legal guidelines suggest. That could substantially increase the proportion of rubble used in building materials, and that in turn would protect the environment in several ways. First, the demolition, processing, concrete manufacturing, and use of recycled building materials all takes place locally. The shorter distances that need to be traveled decrease the impact of material transport on the environment, also requiring far less energy than used to be the case. And since more construction waste is recycled, less storage space is needed. In addition, the less gravel and crushed rock that is removed, the more one valuable resource can be preserved: the landscape.